Now I am going to discuss Gauss's law in magnetism. What was the statement for the Gauss's law in electrostatics? In electrostatics, this was closed integration E dot ds is equal to q by epsilon naught. This is the what you have told net flux, that is electric flux through a closed surface is equal to 1 by epsilon 0 times the charge enclosed by that surface. That was the statement for Gauss's law in electrostatics. Now Gauss's law in magnetism states that net magnetic flux through any closed surface is always zero. Gauss's law in magnetism states that net magnetic flux through any closed surface is always zero. Now let us consider a small area element delta S on a closed surface S. Let us say this is a closed surface and we have taken a very small area element, let us say delta A or whatever you can say this as delta S also. Let us say this delta S, we have delta S. Now what is the direction of delta S? Direction of delta S is this. That means it is outward normal to the surface. If there is a closed surface, then just draw a normal on any point on the surface and which is outward. That will be the direction of that surface at that point. Now see here, this is outward normal. Therefore, the direction of delta S is this. Right? Now, the magnetic flux through this delta S, magnetic flux through delta S is defined as delta phi B is equal to B dot delta S. We have already know this type of expression for electrostatics. The magnetic flux through delta S can be defined as phi B is equal to B dot ds, B dot delta S, where B is the field at delta S. Right? We divide this closed surface S into many small area elements and calculate the individual flux through each and every elementary delta S, each and every elementary surface element. Right? We have taken a small elementary area delta S and flux through this surface is this. Like that, we are going to divide the total entire surface. We are going to divide entire surface into many delta S, infinite number of delta S, and calculate delta phi B through every delta S, and then sum. Take sum of those phi B's, that is those flux through individual elementary surface areas. The net flux phi B will be equal to summation over delta phi, which can be written as summation over B dot delta S. And now this summation can be changed into integration. This summation can be changed into integration if this delta S is very small and number of delta S is finite. Then we may write phi B is equal to integration B dot ds over the closed surface S. And Gauss's law states that this is equal to 0, this is equal to 0. Right? Or in other words, that magnetic field lines entering a surface are equal to the field lines leaving it. Number of field lines enter the surface will be the number of field lines leaving the surface. Then this will be 0 because number of field lines entering perpendicularly into the surface, if that is taken as negative, then number of field lines exiting from the surface or leaving the surface perpendicularly is taken as positive. Positive flux, right? If flux is 0, then this positive flux should be equal to the negative flux. So we can say number of field lines entering any closed surface will be equal to the number of field lines leaving that closed surface. Now from here, what can be inferred? What you can say? If number of field lines leaving the surface and number of field lines entering the surface is equal, then what can be inferred, or what will be our inference? Then you can say, at least you can say that inside the surface there is a north pole as well as a south pole of equal pole strength. If number of field lines entering any closed surface is equal to the number of field lines leaving the surface, then you can say that each and every time there is equal pole strength of north pole and south pole. You cannot get single north pole, you cannot get single south pole. If magnetic monopole existed, then magnetic flux will always have some non-zero value. Hence, according to Gauss's law, we can say that magnetic monopoles do not exist. Gauss's law is one of the most fundamental, or you can say most basic laws of electromagnetism. Gauss's law is one of the most basic laws of electromagnetism. One is for electrostatic and another is for magnetism. There is no source, no sink of magnetic field, that is B. The simplest magnetic element is a dipole or a current loop. All magnetic phenomena can be explained in terms of an arrangement of magnetic dipoles or current loops. Any type of magnetic phenomena you can explain by magnetic dipole or current loops, because magnetic dipole and current loop are identical, are similar. We have already proved that a current carrying loop behaves like a magnetic dipole. That means magnetic dipole and current loops are identical, and by arrangement of magnetic dipoles you can explain any type of magnetic phenomenon. Do you get it? This is the main difference from our electrostatics. In electrostatic, there are you can have monopole charge monopole, electric monopole, which is single charge. You may get positive charge, you may get negative charge. But in magnetism, you cannot get a single north pole or a single south pole. Always you have north pole and south pole together. That is a magnetic dipole.